Hi, I'm Matt, and welcome to Tech Tested. You just made a big boo-boo. You went and bought the cheapest overclocking motherboard you could just because it said overclocking, only to find that you can't because it's thermal throttling. What do you do? Let's face it, we all want to try to save money where we can, and unfortunately, one of the first components that gets cut in a computer is the motherboard. Not that you do without it altogether, you just buy the cheaper model. And this can be okay if you're not overclocking your processor, but when you start overclocking, you really need a quality motherboard to deliver more power to it. Unfortunately, you already bought the cheap one. Cheapo. So what are we going to do to fix that? Well, the biggest problem, at least on the AMD side of things, is the 4+1 power phases just aren't strong enough to deliver the voltage you need to get higher core clocks on your processor. The VRM, the voltage regulator modules, often don't have heat sinks on them, and those overheat as well. So we have to figure out a way to cool those down so we can apply the appropriate amount of voltage in order to get your processor faster. Now this is actually something I've done before, however the method I'm using today is slightly different than the one I used previously. Let me show you what I'm talking about. Here is the motherboard, and a lot of you may recognize it as being one of the cheapest AM3 Plus motherboards there are. And while it serves you just fine if you're not overclocking, once you start overclocking, your VRMs start to get way too hot. So what I did was I took an old heatsink from another motherboard, cut it, and then used thermal adhesive to apply it to the VRM. This resulted in a condition where my VRM never overheated afterwards. And this is actually turned into a pretty fantastic motherboard for what it is. Now, why am I not going to be using the same method? Well, first of all, let me explain what I did. I had this heatsink that I ended up cutting up and applying to the VRM. Fortunately for me, all the VRM were in a row, so I only had to make 2 cuts, and it was very easy. Well, actually, it wasn't easy. That's part of the reason I'm not doing this. But I did it anyway. Another option is if you find a motherboard with a VRM heatsink, much like this one from Gigabyte. This came off of a dead motherboard, it might work too. However, unfortunately, on this motherboard that we're trying to fix, there are capacitors in between the VRM, which means we can't use a single long piece of metal to dissipate the heat. So my solution, hopefully, is we're gonna put some screws on them. We're gonna put the screw to it. I don't know. Anyway, we're gonna put some screws on it. I picked up these screws for less than $2, and we are going to use, initially to test our theory, we're gonna use thermal paste to put it on the VRM, and if it actually works well, which I expect it to, we are going to put thermal adhesive. Now the reason we do this is because thermal paste will not hold it when the motherboard gets mounted in a vertical position. However, thermal adhesive will. So that's why we are going to test with thermal paste when it is in a horizontal position, and then we are going to finish the product with thermal adhesive. But first, let's go over the specs. We have our AMD FX 4130 processor cooled by a Hyper T4 CPU cooler. We have our Supernova EVGA power supply, and we have the terrible motherboard, the ASRock N68-GS4FX motherboard. And the only interesting thing about this motherboard is it supports DDR2 and DDR3 RAM, and that's because it supports processors all the way from the AM2 all the way up to the AM3 Plus. Unfortunately, everything else about it is terrible, so let's try to fix that. First step is to run a baseline test to see what temperatures we're running at so we can see if we're gonna actually get an improvement. All right, after running the test for less than 10 minutes, our processor is running at a nice chilly 35 degrees Celsius, but our motherboard is already overheating at almost 75 degrees Celsius. That's a 40-degree difference. To put that into perspective, the socket on my 990FX motherboard only runs 2 degrees higher than the processor temperature. This is the demonstration of how terrible this motherboard is. By the way, we're also running at a measly 1.36 volts. It's set higher in the BIOS, but because of V-droop and no load line calibration tools on this motherboard, that's what the voltage dropped to. So we really need to look into getting that VRM cooled down fast so we can give ourselves a little bit more headroom to get some overclocking, because as you can see, our processor can take more heat and our processor can take more voltage. It's our motherboard that's killing us. Here we go, ready to fry some computer parts. If you would come over here, I can show you folks what the VRM are on a motherboard. As you can see, these right here, these little black chips are our VRM. And the problem is there's these capacitors in between each set of VRMs. So we can't stick something like this on there to get our thermal dissipation. That's why we have chosen to use these screws. Now these cost us only about less than $2 for the pack of 8, and we only need 6. The method I'm going to use in order to avoid getting thermal paste in unwanted areas is I'm going to apply some thermal paste to this little spatula, maybe. I'm going to apply it individually to each VRM. And the reason you do it like this is because you really don't want to risk getting it on the motherboard in places it doesn't belong. So there's 1, there's 2. And after each set of 2, I'm going to put on the screws. Now, unfortunately, these screws are ever so slightly too big. Now, keep in mind, this is not thermal adhesive. These are not glued down in any way. If this works, we are going to be applying some thermal adhesive for a more permanent solution. We have our screws applied, and unfortunately, there's no way for us to put any downforce on the screws to really get that heatsink set, but we're gonna find out right now if this works, and if it does, we're gonna do something to make it a bit more permanent. That didn't really work. We're still running around 74, 75 degrees Celsius on the VRM. But I will not be defeated. We can still improve your bad motherboard, and I will show you how. I thought, next step, we need to get air flowing across that. That's one of the biggest problems with tower coolers, is when you have a tower, you don't have any air blowing down onto your motherboard. This is part of the reason VRM tend to overheat. So I mounted this tiny little fan. We're still running the same instance of Prime 95. Mounted this tiny little fan. I picked this fan up for, I think, $7. And our temperatures, if you look over at our screen, have dropped. If you look right here, our CPU 10 is now at 65 degrees versus the 78 that it was. And we are still running all 4 threads on Prime 95 without any problems. So what we're gonna do, we realize that this is not a permanent solution, especially in a case environment. I mean, you can mount typically a fan in your case that will blow, especially if it's top mounted, it will blow down on your VRM, but there's no guarantee. So we're gonna go to the hardware store and we're gonna try to find a way to mount this properly so that you can have a long-term improvement on your motherboard temperatures. So we are currently looking for some sort of bracket that we can mount the fan to and mount it to the motherboard without shorting anything out on the PCB. Unfortunately, this is a very small hardware store and I'm not finding anything. I was thinking something along the lines of this, but I don't know if there's any screws adjacent to it that will allow us to get it close enough so that we can still have it hitting the VRM. So let's keep perusing. Jeez. Really not seeing anything. It would appear that I've found us a nice cheap L bracket for a mere 40 cents. You know what? At 40 cents a piece, we're gonna buy each one. I know that's wasteful. It is necessary, and I'm gonna need one more piece of hardware, which will be a straight bracket. I wish I'd brought the fan so I would know what the dimensions are of the holes. I don't remember. So what we're gonna do is we're gonna get this bracket. So here's my plan. Where the motherboard mounts to the chassis, I plan on mounting like this. So the fan will get mounted here because the screw's too far to one side. So we're gonna mount the fan to this bracket. And then we are going to have to, unfortunately, we'll only be able to use 1, maybe 2 of the screw holes, but that at least gives us a mount. Now we also have to find a way to mount it so that it's not gonna short it. So we're gonna have to find something to put between this and the screw on the motherboard. But right now we have spent 90 cents between these 2 brackets, and I'm actually gonna put this one back because I don't think I'm gonna use it. So it would appear we have all of our hardware. We have a couple L brackets, a couple bolts, and unfortunately some very ugly but very necessary white, very thin zip ties. So we're gonna go check out. So we've got our assortment of brackets. I don't think I'm actually gonna need everything I got. I think I am still just gonna be able to use the motherboard screw, which goes in this hole. But we're essentially gonna be building a bracket to hold our fan on. But step one is we need to cover the bracket with tape. Now I would recommend something more along the lines of electrical tape, but we're going to use this tape to prevent any shorting out on the motherboard. So don't cut yourself if you do use that method to cut the tape. I'm going to poke a little hole in the center here with a screw. I'm going to run our motherboard screw in there. All right, it's pretty sturdy. Next step is we need to mount this bracket. And I haven't determined yet, wow, that sticker really sucks. I haven't determined yet what the best method is gonna be. How far over, I think we'll have to put it in this. Then we're gonna mount our fan like so. Actually, that's a little high. You know what, we can mount it like, we'll figure it out. We'll figure it out. There's still time. So we have our screw, a lock washer, and a nut. You could get away with doing just a lock nut, but I really don't like lock nuts. They're a pain in the butt. All right. There is our fan bracket that we have just built. Not the most elegant thing. And that is still a little high. So here is our less than elegant solution. We have a fan with a homemade bracket attempting to blow down on the VRM. If you have a case with an overhead fan, you might just want to use that fan to blow on your VRM. And I'm not sure if these screws are doing anything to help our temperatures, but we will do something to find that out. But first, to testing. After we fixed our shorted out motherboard caused by our jerry-rig mounting bracket, we fixed that by wrapping it in tape. We are now well underway into our Prime 95 run, and as you can see, we are sitting at a steady, cool 64 degrees Celsius with this fan blowing on our VRM. Now, here's the big question. Will that have the same result when we remove the screws? Because if the screws aren't doing anything, there's no point in going through that step, and you just need a fan. So what we're gonna do next is we're gonna remove the screws, and if the screws are contributing to better temps, we will make them a permanent fixture. If not, we're gonna leave them off. So we removed our screws, and we came to a stark realization. They actually negatively impacted the cooling performance of our VRM. We are actually sitting in Prime 95 at a mere 62 degrees, which gives us 8 degrees of thermal headroom for adding voltage to this processor to get it past the 4.2 gigahertz we're running at now. We aren't gonna spend our time actually trying to overclock this thing right now, but that just goes to show you, with just a little bit of extra air flowing over your VRM, you can go from pushing 77, 76 degrees all the way down to 62. That's a 15 degree performance increase, and that will give you some overclocking headroom in the future. And that, my friends, is how you help improve your bad motherboards. Thanks for watching. As always, don't forget to like and subscribe. Follow us on Facebook and Twitter. Leave a comment if there's anything you'd like us to cover in the future. Check out our podcast at iTunes or Google Play, and check out our forum at techtested.io.